Hello students, today we are going to start a new chapter of class 12th mathematics, that is vector algebra. Now in this vector algebra, what do we understand by the term this vector? What do you mean by vector? So before this, we know that we have categorized all the quantities in two forms. One are scalar and another one are known as vectors. So what are scalars or what are vectors? Scalars are the quantities which are having only magnitude. It does not depend upon the directions. But vector quantities are the quantities which are having magnitude and as well as direction. Then vector. So how can you define vector? Vector, those quantities which have magnitude as well as direction. These are called vector quantities. For example, let's see, if I throw a stone with the speed of 5 km, so it is having the magnitude only 5. I have not mentioned any direction here. It means it is a scalar quantity. But if I said that if I throw a stone with a speed of 5 km per hour in the direction of east, now here in this case I am mentioning that direction also with the speed. So here this particular type of quantity are known as vector. Now how will you represent a vector quantity? If I have written here 5 km per hour the speed of a stone, and here also I am giving the speed of a stone, but how can you say that this is a scalar or this is a vector? Is there any difference in the representation of a scalar quantity or a vector quantity? Yes, there is. Now how can you represent this? So before this, let's see one thing. A note is there, that is, what is note? Those quantities which are having only magnitude, there is no direction, only magnitude, then such quantities are known as scalar quantities. Now how can you represent a vector? Suppose here is a one point and here is another point. Let it be A and here it is B. And this is AB. Magnitude of AB, let the length of this AB is again 5 meter. But I am not mentioning here any direction. But if I mention the direction of this AB by putting an arrowhead here, now this is represent a vector having particular direction. So we can represent a vector by putting an arrow over the quantity, or I can also represent this as A is a vector, but it can be a scalar quantity. It is only a vector when I put an arrow over the head of this A. Now this is a vector, but this A is only a scalar because here I have not mentioned any direction. But this is a vector. Why? Because here I have mentioned this arrow. This arrow means direction. So this is the clear representation of vector. Next, see here, AB or simply a vector. This sign of arrow, AB vector, Here the point A, from where the vector starts. The point A from where the vector start is called initial point, and the point B where it ends is called terminal point. So students, can you please tell me, in a vector PQ, which particular point is terminal point and which particular point is a initial point? Here, let's see, the vector starts from this Q. That's why Q point is termed as initial point. It is the initial point. Why? Because the vector starts from this Q and it ends at P. That's why this particular point P is known as terminal point. Okay, this point is, I think, clear to all of you. Which particular point is initial point and which particular point is terminal point. In the same way here in this case, now here which particular point is terminal point and which particular point is initial. Now here in this case A is the initial point because the vector starts from this A, and this B termed as the terminal point because the vector B ends at B. Now what is the position vector? What do you mean by the position vector of any point? Now see, if suppose here in the Cartesian system of space, it is x, it is y, and it is z. Now here it is termed as origin, having the coordinate 0, 0, 0. And here is one point, let it be P, with the coordinate x, y, z. Okay. Now what this particular coordinate x, y, z actually represents? This x, y, z represents the position of this P, with respect to origin. So how can you use these coordinates in vector? Very simple. First of all, this x gives you the point on x-axis, and this y gives you the point on y-axis, and this z gives you the point on z-axis. Now actually, what is the particular direction in which this point P lies? We can give the direction or the position of this point P by using the vector OP. Now, how can you write this vector OP? Very simple. First of all, we have to write OP vector. This is the vector which I am going to write here. Now in vector, what I know that in vector there are two particular things. One is magnitude and another one is the direction. So what is the direction of this x coordinate? Magnitude is x, but I don't know the direction. Yes, direction is on x-axis. So we have to use the direction of this x, and the direction of any vector is represented by another vector which is known as a unit vector, and this unit vector is represented by putting a cap over a term. That here I am putting a cap over this I. It means this I is a unit vector which is giving the direction of x-axis. Now then y. Here the y is the magnitude of this point on y-axis, but I have to write here the vector form, so we need to write here the direction also. So what is the direction of this y? The direction of y-axis, consider this is j cap. Cap means unit vector. Unit vector, what is unit vector? Unit vector gives us the direction of a quantity. Now plus z. Z is again a magnitude in the z direction, and to represent a vector I have to write a direction also in the form of k cap. So we can represent a position of a point P in the form of vector by using the coordinate given to us as OP vector, or this is OP vector. I can also term it as R vector. R vector can be written as xi plus yj and plus zk. Here I cap, j cap and k cap, these are the unit vectors. Unit vectors. What unit vectors represents? Unit vector represents only the direction. Only the direction. And what is the magnitude of this unit vector? As it is a vector, it is having both. One, the direction, and second, the magnitude. For unit vector, the magnitude is always 1 and the direction is given by these caps. So this is a vector giving the direction of P. That's why it is also known as the position vector of P. Now, what do you mean by the magnitude of a vector? How can you find the magnitude of a vector? It's again a very simple. Again, here I am taking x-axis, it is y-axis, it is z, it is origin, and this point P, having the coordinate x, y, and z. And this vector OP vector, this OP vector now can be written as xi plus yj plus zk. This is a vector OP. Now, what is the magnitude of this OP vector? What is the magnitude of this OP vector? It's again a very simple thing. Just to find the magnitude, it means I want to find the length of this OP. For magnitude, we have to find out the length of this OP, and I can represent it, length means the magnitude, by putting the two vertical lines like this around a vector. So here this two vertical lines and between the R vector is written, it means it gives us the magnitude of a vector. It gives us the magnitude of vector. Which vector is this? R vector. Okay. Now how can you find the magnitude? Again, how can you find the length of this? In three coordinate system, suppose here I am drawing a cuboid and considering this particular point or this line, it is considered as x, it is y, it is z, and the coordinate of this particular point, let the coordinate be x, y, z, or we can say the side of this cuboid, let it be y, the side of the length of this cuboid will be y, and this is z. So what will be the length of this diagonal from this origin to this point P? What is the length of diagonal of this OP? Length of diagonal will give us the length of OP, and this particular length of diagonal is OP, and which can be represented or can be calculated by using this formula, x square plus y square plus z square, and this is the length of OP. That's why it is known as magnitude of the vector OP. So how can it be written? Let's see. It is written as like this, represented by two vertical lines. Here are these two vertical lines. And then OP vector, two vertical lines around a vector represents a magnitude, and this is the formula to find the magnitude of a vector. Okay, is this clear to all of you? Now the direction cosines. What do you mean by the direction cosines of a vector? So direction cosines means, so before this, just see one thing. If I draw the axis, let here it is z axis, it is z, and then it is x, and then it is y, and it is origin, and this is again a vector p. Now what are the direction cosines of this vector OP? Direction cosines, direction, always it is given by an angle, and cosines, we all know this is cos of angle. Suppose cos A, it means it is cosine of A. Now here angle and cosine. So this vector OP makes an angle, makes an angle alpha with the x-axis. Let it be alpha with the x-axis, and another angle it is beta with the y-axis, and here it is gamma with the z-axis. So these are the angles giving the direction of this OP vector, but these are not direction cosines. Direction cosines means the cosines of this angle. So direction cosines of a vector are cos alpha, this is the direction cosine along x-axis, then cos beta and cos gamma. These are the cosines of the direction or the angles of OP vector along coordinate axis, and these are known as direction cosines and can be represented by L, M, N. And note one important thing, that the sum of the square of these direction cosines is always 1, okay. What the points to remember? It is the sum of the square of all these three direction cosines is always equals to 1, like this. See here, alpha, it is beta with the y-axis, it is gamma with the z-axis, and the cos of these angles are known as direction cosines. Let's read it once. If alpha, beta and gamma are the angles which a directed line segment OP, this OP makes with the positive directions of coordinate axis OX, OY and OZ respectively. Okay, is it clear to all of you? Then cos alpha, cos beta and cos gamma are known as direction cosines of OP. Clear? And these are represented by L, M, N. Okay, is this point clear to all of you? Yes. Next, types of vectors. So in these type of vectors, first is null vector or zero vector. A vector whose initial and terminal points coincides and magnitude is 0 is called a null vector, and it represented by a zero vector. When it is a 0, when the starting point of a vector A and it is B, so it is known as AB vector. Okay, is it clear? But the initial point and the terminal point coincides with each other. It means here it is a point where A and B lies at this particular point, then it is a zero vector. It is a zero vector. So what is the particular definition of this null vector or zero vector? when initial and the terminal points coincides and the magnitude is 0. Magnitude is 0. That's why it is a null vector or a zero vector. Next is unit vector. Yes, this we all know what is unit vector. Unit vector is of unit length. It means the magnitude of any unit vector will be always 1. Of unit length means magnitude 1. The unit vector in the direction of what? In the direction of A. Suppose here a vector A. I am writing here a vector A, and this particular vector is having two quantities. One, it is having a magnitude which can be represented by a vector between the two vertical lines, and then the direction of this vector which is represented by a cap. A cap. It means a vector is having the two things. One, magnitude, and another, the direction. And direction is given by this unit vector. It is cap. Then a cap means the direction of a vector can be find out by dividing the vector by its magnitude. See, I am getting this from this particular formula. A vector is equals to modulus of A. Modulus of A means A, and this is the direction. That's why A cap is equals to A vector upon A modulus. This is a way to find a unit vector. Unit vector means direction. Unit vector means direction of a vector. So the direction of any vector A can be find out by this particular formula. A vector upon A modulus. Now collinear vector. Next type is collinear vector. Collinear vector means collinear. Collinear. When the few points 1, 2, 3, 4, 5 all lies in a same line, then these particular points are known as collinear. Now what is the meaning of collinear vectors? Let's see. Two or more vectors are said to be collinear if they are parallel to the same line. If they are parallel to the same line, irrespective of their magnitude and direction. Whatever will be the direction of two vectors, whatever will be the magnitude of two vectors, but if the given vectors are parallel to a given line, then those two or three vectors are known as collinear. For example, it is a line. It is, here I am drawing a line. It is a line. Okay. It is a line. Given line actually. It is a given line. And I am having a two vectors. One is A in the direction of this, and another one is B in the direction of this. Now here these two vectors are of different magnitude. See, here the magnitude is this, and here it is of negative direction or opposite to A, and the magnitude is very small in comparison to this A vector. Here these two vectors are of different magnitude and having the different direction, but these are parallel to a given line. That's why A and B are known as collinear vector. Okay. But when two vectors are collinear, then one condition is always applies. That is, when two vectors are collinear, then A is always equals to lambda times of b. It means one A vector and B vector, if are collinear, then they can be represented in this form. A is equals to lambda B. Then only we can say that these two vectors are known as collinear vectors. Next type is equal vectors. So when two vectors are said to be equal, it's very simple. Two vectors are equal when, see, two vectors are equal if they have equal magnitude and the same direction. If two vectors are having same direction, same magnitude, then they are known as equal vectors. But one thing, it is regardless of the position of initial point. It means here I am drawing a vector A and B. Okay, A and B. And another vector I am drawing here, PQ. Now see, here the direction of AB and the direction of PQ both are same. It means they are having the same direction. These are having the same direction. Okay, is it clear? Direction is same. Now what about magnitude? Now see, A and B is having the same magnitude as this PQ. The length are same. Here the direction and the magnitude, again they are having the equal magnitude. Now for these two vectors, we are having the same direction, we are having the same magnitude, but their initial points are at different place. Here initial point is at A and here initial point is at P. But still they are known as equal vectors.